We're going to talk about number sets. The first number set we have are the natural numbers. These are counting numbers, 1, 2, 3, 4, 5, so on. The number set after that are called whole numbers. In addition to the natural numbers, it includes 0. What I'm going to do is represent these natural and whole numbers in this diagram I call a sneaker diagram. So I'll start with the sneaker here. These are the natural numbers. And then I'll write whole below it and add a 0 here. This is basically every level below includes all the levels above. And so this is my way of representing the whole numbers include 0 and the natural numbers. I have integers next. These are numbers that basically include the negative natural numbers. Think about a number line. The tick marks on a number line represent the integers. They go on forever and ever. So they include the whole numbers and they include the natural numbers, so they're going to be the next level of the sneaker, including negative natural numbers. The next level below that is the rational numbers. The key to rational numbers, or remember what these are, is look at the word ratio. Ratio is saying one number to another number, aka it's related to fractions. Rational numbers are going to be a fraction of an integer over another integer. Now, does this actually include these sets above it? Yes, because I can write 4 divided by 1, and that's 4. That's a natural number, it's a whole number, it's an integer. I can also write 2 divided by 5. This doesn't simplify, so it's not an integer, but it is a rational number. Rational numbers also include repeating decimals. In your class, you may learn a little bit later how to convert a repeating decimal into a fraction. However, the simplest repeating decimal, 0.333, going on forever, this is 1/3. We represent repeating decimals by having a bar over the number, the repeating part. So this is the same thing as this above. If I have a bar over this is the same thing as 0.1414, repeating forever and ever. So your rational numbers are basically fractions of integers, and that will include repeating decimals because, again, this is a fraction of integers. So we have rational numbers. And then you can write P over Q is a way of representing the ratio of two integers. You can write 0.3 bar just as a reminder that you've got these examples. It's not just this, these categories, but these visual examples will help you remember. Sorry I drew the diagram so small. Next is irrational numbers. Irrational numbers are basically all the other numbers that can be on a number line, including in spaces in between, that are not covered by the rational numbers. We actually can't cover every single number using a ratio of integers. These can be non-repeating, non-terminating decimals. So what does that look like? It could be something that has a pattern but does not repeat. Right? That has a pattern. I'm adding a 0 in between each one every time, but there's no way for me to write this as a rational number, as a ratio of fractions, a ratio of integers. Also included are radicals that do not simplify. Square root of 16 does not work because that turns into 4. But square root of 2, that's not a perfect square. So that will end up, if I throw it into a calculator, to be a non-repeating, non-terminating decimal. Also a couple special numbers. Pi is an irrational number. That's used early on. Later on you will learn the number e, which is also a very important irrational number. So this is basically all the other numbers on the number line that aren't rational numbers. And because they do not include rational numbers, we draw them on the side here. And then we can draw little examples here of a non-repeating decimal and pi. If we combine rational and irrational numbers, those include all the numbers on the number line, including in between the spaces. Those are known as real numbers. So basically, all rational numbers and all irrational numbers. And so that would represent the bottom of the sneaker because it includes all irrational numbers and rational numbers. In a more advanced math class, you'll learn about complex numbers, which is and imaginary numbers, but that's sufficient for Algebra 1.